Good afternoon, everyone. Sorry we're a little bit late. We were trying something new. We were trying to live stream directly to the event, thinking that maybe that would help people find our live stream a little easier, and we couldn't even find it ourselves. So I don't know where it went, but we're going to start over. This is take two. Good evening. Thank you so much for coming out. This is the Ward Beecher Planetarium crew. Joining us today for another public planetarium show online. So we're back again this week. This week we'll be talking all things space exploration. So we'll talk about missions to the moon and beyond, past, present, and future plans. But first, we're going to start with our Star Talk. We do this as we do with all of our shows, and I'm really excited to share with you all our guest speaker for our Star Talk. It is our a planetarian graduate, Nick DeLuca.
Hello, everyone. No pressure, I guess.
We were talking before the show that Nick predates me. He's older than I was, so he started working at the planetarium as a student several months before I was hired on as the planetarium lecturer. So he was there when I was hired, and he graduated, oh gosh, was it 2018 or 2019?
2019.
Okay, what year is it? Yeah. So just last year you graduated, and you're back. So thank you for joining us today to lead our Star Talk.
Absolutely.
Afterwards, Kurt will lead a little section of our show.
Heidi-ho, me again.
And I'll wrap things up. But I do want to quickly introduce our other wonderful student workers who's going to help moderate the Facebook chat and answer your questions and relay them to us so we can have some great discussion. We have Eleni.
Hello.
Nishan.
Hello.
Howard.
Hello.
And Jenny.
Hi.
So without further ado, do you guys want to get started?
All right, I'm ready.
All right.
Okay.
I'll be sharing my screen here, but Nick's going to be talking, so I'll hand it over to you, Nick.
All right. Well, good evening. And as Tiffany mentioned, I'm Nick. I'm a YSU alumnus and former employee of the Ward Beecher Planetarium. It's really good to be here. I'm glad to help out with one of these shows. So the plan for this is to hopefully give you a brief talk about the current night sky, followed by a look ahead at what is to come in the next few months. So to start off, to set the scene, we'll be looking at the sky over Youngstown around 9:30 p.m. I'll tell you now, we're already facing north, as you can see by the compass point markers. That might be obvious in here, but I know none of us have giant ends in our backyard, so a little bit later I'll tell you how to make that clear in your backyard. But for now, we're going to focus on two rather bright objects off to the western part of the sky that's about to set. The first bright object is the brightest object in the night sky when it is up, and that is the moon. Now, I would like to point out that it is a waxing gibbous phase moon. It does not always look fully illuminated like it does in Stellarium app here, but if we zoom in on it, you'll start to see a few more of the details. While Tiffany is working on that, as I mentioned, it's a waxing gibbous phase, so the majority of the moon is lit up and is still growing with light. That will be full noon in the next few days. But as we see it here, you can see the terminator line where the shadow meets the light. You can see a few craters, and with a pair of binoculars and telescope, you are even able to see some light in the craters on the dark side of the moon, which is pretty cool. Now, if we zoom back out, you'll notice that although it isn't actually this bright in the night sky, it's not a full circle of light in the real night sky. It does add pollution to the night sky, what we call light pollution, which is just interfering light in our atmosphere that makes it harder to see dim objects. Now, this is a major reason why we can't see everything there is to see in the night sky, especially in a city like Youngstown. The reason light pollution is so bad around here, however, is not completely due to just the natural ambient light, not just from the moon and the other planets that we see. Collaboration between Italy's Light Pollution Science and Technology Institute and the US Department of Interior's National Park Services published an article in June of 2016 mapping global light pollution. So what they did is they were showing where high amounts of man-made light pollution are produced around the world. So although the moon makes it difficult to see dim objects in the night sky, especially for waxing gibbous, full moon, even waning gibbous when it's starting to get the shadows starting to creep up more and more, man-made light pollution is the top reason that it's said 80% of Americans can no longer see the Milky Way from their location. And I'll get to that object a little bit later. But for now, I want to return to the other really bright object that happens to be up right now. And that is our nearest neighbor planet in space. Of course, this is Venus. Now, Venus is bright not because of its size, rather because it is very reflective due to the thick atmosphere reflecting sunlight. It is also very bright because, again, it is the closest planet to us. For your reference, as far as light and radiation reflection goes, there's a term called albedo, which is in short a 0 to 1 scale of how reflective a surface is, where 0 is non-reflective and 1 is perfect reflection. Now this is a very rough definition, but for your reference, Venus's albedo for light is about 0.75, or about 75% is reflected, while the moon's is only about 0.12, or about 12%. So now that we've found the two brightest objects in the night sky that are in our solar system, they are only temporary point markers. As I said, they're in the western night sky right now, but they will not always be there. So it might be a little bit more helpful for me to show you some more permanent indicators for a direction, and that direction will be north. The trick for this to work is you can only be about as far south as 30 degrees north of the equator. So you can be as far south as 30 degrees north latitude of the equator to see this without setting, so for it to be a circumpolar constellation or object. For your reference, we are at 41 degrees north latitude. The top of Florida is around 30 degrees north. So keep in mind, like I said, the planets and moon and all the objects in the sky will always move east to west. So they won't help you pointing west always. So we're gonna start looking north with a very familiar group of stars known as the Big Dipper. This group is made of 3 stars that form a handle, 3 stars that form a handle, and 4 stars that make a cup. The reason this group of stars is relevant is because it never rises or sets, so you'll always see it in your night sky. It will always be above the horizon at night, making it a circumpolar group of stars. This is why you can always use it to find north, because it won't set. From this, to find the star that points us north, you'll take the 2 stars at the end of the Big Dipper's cup, make a line from the bottom through the top of the cup until you run into the next brightest star. That star's name is Polaris, also the North Star. Now this star is not important to us because it is the brightest star like some people may think. So you can see there are many other visible stars in the view that are much brighter than the North Star. So what does make this star important is the fact that the north pole of our planet's axis points at this star. So if you imagine a pole coming straight out of a globe on either side, the pole on top, or the North Pole, would be pointing straight at the North Star. And this is why stars appear to rotate counterclockwise around it as time proceeds, as stars and other objects rise in the east and set in the west. So as time passes, we can start to see this happen, and I will let Tiffany forward us in time to about 1:30. And as you'll notice, the North Star stays rather stationary while everything around it moves to the west. And we should see.
Sorry, I moved forward a little too far.
That's perfectly
I'm going to go
fine.
back. So this is not how the Earth moves.
This
I'm
is
just
part
pressing
of,
all the wrong buttons today. Ah,
this is the live portion of the show. There are some technical difficulties, but Tiffany is very experienced with how to work around these.
I am experienced, I promise. I know it doesn't look like it.
Um, so one thing to notice as the stars rotated is
That's
that new
about
objects,
1:30.
good?
We're good. We're set at 1:30 a.m.
All right. Now I was saying, as I was saying, one thing to notice is that as the stars rotated, new objects have appeared and some have gone away. So I think the moon is gone. I can't really see it from my screen, but the moon and Venus should be either setting or gone. But before I get into those, should I stop for any questions so far? No? All right. So as I mentioned,
Sorry to interject. Somebody was asking if they could see Virgo in May.
Virgo. So I believe that is a yes. You would just use the Big Dipper again. Instead of the 2 pointer stars at the end of the cup, you'll use the 3 stars at the handle. That'll arc towards a star called Arcturus, which is very handy. And if you continue that line, you can spike to another star in a straight line that is on that arc called Spica, rather. Now, Spica is the brightest star in the constellation Virgo. So you are able to see Virgo in the springtime sky, yes. All right. All right. So as mentioned, some objects are around all the time called circumpolar stars. They never rise or set, hence the name circumpolar. They circle the pole. But the farther away from the North Star you get in the sky, the more likely you'll run into seasonal objects, much like Virgo is a seasonal object. These objects do rise and set, and they are only visible during certain times of the year. Since we've moved forward in time, we've moved away from our springtime sky somewhat. So it is either very close to overhead or more moving west. And some of our summertime sky is visible. And this is identified with 3 bright stars that form a triangle, commonly called, you guessed it, the summer triangle. How creative. Now, each star is the brightest star of their respective constellation. Being the brightest appearing star of the group, Vega, is a part of the constellation Lyra the Harp. The constellation itself is pretty dim and kind of hard to see in light polluted areas, but it makes the shape of a parallelogram in the sky. Funny how the Greeks made some of these constellations. If you know Kurt and Tiffany's rendition of the little dog being the galactic pencil, you'll know what they mean. The next star that is the actual brightest star of the trio, Deneb, is the tail feather star of Cygnus the Swan, also referred to as the Northern Cross, which is an asterism. Much like the Big Dipper is an asterism to the constellation Ursa Major, the Big Bear. An asterism is usually a piece or part of a constellation, or even just a random pattern in the sky that's not globally recognized by some sky lore. Many different cultures have their own lore, which can be found in the Stellarium app if you want to download this and see for yourself later on. But back to the swan, it is easily distinguished. It is a cross that seems to be flying through the haze of the Milky Way galaxy. Yes, the clouds and atmosphere have been turned off in Stellarium. So this stream of light that you're seeing, that you're looking at, actually signifies ambient light produced from the Milky Way galaxy, our home galaxy, a barred spiral galaxy that houses our sun, as well as anywhere from 100 to 300 billion with a B stars. The light doesn't entirely consist of pinpoints because some of the sources are just too far away. They're so numerous, and sometimes they're just too small to focus, making this collective light mesh into a glow. The pinpoints we do see are all usually stars in this glow that are just close enough and distinguishable enough to stand out amongst this vast conglomerate that we call our home in the cosmos. But as I mentioned, Cygnus appears to be flying across the stream, along with our final of the 3 constellations in the Summer Triangle, Aquila the Eagle, signaled by the dimmest and closest of the 3 main stars, Altair. Altair is found as the center star of 3, marking the eagle's face. It's turned to the side like the eagle on a quarter coin. The head and the body make the shape of the 7, and the wings on the side as shown by the outline. So when you look and find the Summer Triangle, just remember, you're actually just looking at 2 birds and an old music instrument. There is one last constellation I wanted to mention that isn't part of the Summer Triangle. At least one of my colleagues would be disappointed if I didn't mention, but there's a small and very faint constellation, Delphinus the Dolphin, that can be seen just between Deneb and Altair. This cute little scamp just appears to be jumping out of the Milky Way on its swim alongside Cygnus and Aquila. But now that I've shown you a few bright stars that you can see in your night sky, I figured we should probably end this on some planets, since Venus was the only one we saw it in the early evening. The rest of the planets you can see are in the very early morning. So now, if Tiffany fast forwards us to about 5:30 a.m., we'll be able to see 3 new planets. And I'm also going to have her face south for us so we get a better look at that stuff. Great job piloting, by the way. This is one of the first times she's piloted for me. When I worked at the planetarium, I was doing most of the piloting for her. So she's doing a very good job. I appreciate it. All right, so the brightest of the 3 planets is the biggest planet in our solar system and home to at least 79 confirmed moons, that is Jupiter. The slightly golden planet in the middle of the 3 is the planet Saturn, known for its lovely ring system, which can be brought in easily with most pairs of binoculars or telescopes. And the last rather red planet is Mars, our other neighbor in space. Mars is not red because it is hot, rather it is due to the abundant rust on the surface of the planet. So you are actually looking at sunlight reflecting off the surface dirt on the planet that gives it this intrinsic red shade. Now, if you've noticed already, the planets, the moon, and even the sun, in some capacity, have followed roughly the same path across the sky. That's not by some major coincidence. This path that they follow is called the ecliptic plane. Much like the plane of our galaxy is a relatively uniform line across the sky, the ecliptic plane is where the major solar system objects tend to reside. Now, if we look at that line in the sky, we can start to see a trace. It traces past a bunch of constellations people might recognize. At the far west end of the line, you'll see Antares, the heart star of Scorpius the Scorpion. And just east of that, you will also notice the teacup that signifies Sagittarius the Archer. So if you notice, these are 2 major constellations in a list of 13 zodiac constellations, star patterns, that lie along this ecliptic plane, the plane of our solar system. Now you notice I said 13 constellations, not 12. Between the Archer and slightly above the Archer and the Scorpion is a little known constellation that's left out of most zodiac maps called Ophiuchus the Snake Charmer. Conveniently, if we turn on the constellation borders, this constellation appears to take up more space on this ecliptic plane line than Scorpius does. Do with that information what you like. Now, as I mentioned, this is a brief star talk just to give you some information. I know it might be a little bit to take in, but what I hope this did is give you somewhere or something that might inspire you to look up. Between planets, the moon, summer being around the corner, or discovering an entirely new constellation. This is just a very tiny list of things you can do in your own backyard. This stuff is free. I think we can all appreciate if it's for free, it's for me. Now, I understand if you're in a very bright location, it might be more difficult for you to go outside and look at this stuff. But as I mentioned earlier, I also suggest the very useful and also very free app Stellarium to follow along with us in future videos or even to explore in your free time. There are mind-numbingly astronomical numbers of things you can find in the sky above you, and I hope this gives you a gateway to observing the universe. I'm going to hand it back over to Tiffany.
We have one
Wow.
more question.
Thank you. We have some questions, Nick.
Okay.
Matthew asked, how is it possible to see the Milky Way galaxy if we are in it?
How is it possible to see the Milky Way if we are in it? So as I mentioned, it has to be relatively dark, but for us to actually see it since the light's so faint. But the Milky Way is made of, as I mentioned, 100 to 300 billion stars. So all of those stars are creating some light, and that light is meshed together to create the glow that creates that line. So you're looking at actual starlight along with some dust. You can see the dark areas of the Milky Way. That's starlight on the other side being covered by dust. So you are able to see stars, you know, that show us a rough idea of what our Milky Way looks like. And that's how we were able to sort of, kind of visualize what maps would look like. If anyone else has anything.
Yeah, I think you did a great job explaining, Nick. It's we are surrounded by the Milky Way because we're inside of it. So it's shaped like a flat disc. So that's why we see sort of this band in the sky, but it wraps around our entire sky. So just like we live on Earth, we live, you know, in our atmosphere, in Earth, we can look around and we can see Earth because we're a part of it. It's very similar to that.
I will add too, they got the idea of the shape by looking at other galaxies in the universe as well and figured, hey, this one looks kind of like what we're seeing, so we must have a spiral galaxy.
All right, well, I think that wraps up our Star Talk. Thank you again so much, Nick. If you guys have questions for Nick, feel free to continue on in the comments. I'm going to switch this back over to Kurt as we switch over to discussing space travel and maybe answering some of the questions of how do we know some of the things we do. It started because we were stuck here on this planet looking up, and now we can say we've left it. And so I'll hand this over to Kurt.
Hi again, everybody. Yes, I get to the historic aspect of things. If any of you visited the Ward Beecher Planetarium last year, we celebrated the 50th anniversary of the first moon landing in July of 2019. And we had a great display on it. So since I put the display together, I get to do this first bit about the Apollo space program. The Apollo program grew out of what we call the space race. For our younger visitors, it used to be the United States and the Union of Soviet Socialist Republics, or the USSR, which got reduced and is now just Russia, and a lot of the other Soviet Socialist republics have gone away. But at the time, rather than to get in a shooting war with them, they had these contests back and forth to see if they could one-up one another. Well, after World War II, one of the things that came about was traveling in space, thanks to some technology the Germans started to use during the war, the V-2 rocket. In the late 50s and the early 60s, the Russians were ahead of us most of the time. But with our Mercury program and our Gemini program, we caught up to them, and eventually we reached the moon before the Soviets did, thus winning the space race. And this is kind of how we do it. Now I'm going to try to share a video. We'll see how this works. Let me see if I can do this. Where's my share screen? I've lost my controls here. Oh, does that help? That helps. Oh, I went into full screen mode. Hold on. Ah, there we go. Now I should be able to share screen. Okay. So here we go. Oh, and it's not sharing that one. 1 second, everybody. Once again, live television, or video, as it were. Okay, there's that. It should be sharing. Let me go back to here. Try to share. I went to comments. That's not what I want to do. Share screen. It's not giving me the thing as an option.
Would you like me to share it?
No, I think I can get it. Just give me a second.
Okay.
Actually, I'm going to stop share and then try it. 1 second. Okay.
You can hear Kurt's
click.
his clock in the background keeping time for us.
Yes,
We're
I'm sorry.
running a little bit behind schedule, but I think it'll be okay.
Can you see this on my screen, Tiffany?
I cannot see anything on your screen. You're not sharing a screen.
Okay, maybe I need to have it running. Or
it has to be up as a window to share it.
Yeah. So let me try it again. Share screen. Ah, there we go. Okay, here we go. So we're going to start with the Apollo rocket. The Saturn V rocket was the most powerful rocket ever made, and its first flight was on November 9th of 1967. The Saturn V burned more fuel in 1 second of flight than Charles Lindbergh used in his entire journey across the Atlantic Ocean in the 30s, which is amazing. It went from paper to design of flight in 6 years. Formal development began in 1961, and its first flight, like I said, was 1967. It had 13 mostly successful missions. The one you're seeing here, Apollo 8, was the first time it carried the command module in. Apollo 8 went around the moon 10 times with the astronauts Frank Borman, Jim Lovell, and Bill Anders, and they took these pictures of the surface of the moon. And they captured this image, which was the first view of Earth from space, one of the most famous pictures of the 20th century. Now, Apollo 9 tested the lunar module. Apollo 10 was a dress rehearsal for the mission by these three gentlemen. Apollo 11, Neil Armstrong on the left, Collins in the middle, and Buzz Aldrin on the right. They took off on January 16th, 1969. Here is the descent of Buzz Aldrin and Neil Armstrong to the moon on July 20th, 1969. They landed in the Sea of Tranquility, or Mare Tranquillitatis, which is now known as Tranquility Base because they landed there. And they were on the moon for 2.5 hours on this flight. The mission was successful and returned to Earth on July 24th, 1969. Now, they did have some trouble going down. What you're seeing here is a rock-strewn field, and when Neil Armstrong saw this, he took control of the LEM and flew over until they found a landing site, which you see here taken with high-res pictures from inside the LEM. These are actual pictures that Buzz Aldrin snapped of the moon's surface before Neil Armstrong went out on the surface. And of course, we all remember the famous words that Neil Armstrong did when he reached the surface. This is Buzz Aldrin filming him as he's going down. That's one small step for man, one giant leap for mankind. He stepped off, put his foot on the surface, tested the surface, make sure it could hold his weight. They weren't 100% sure of that at the time. And then he stepped back up and snapped the picture you are about to see in just a moment. As it comes up here, I don't have this perfectly timed out, as you can tell. But there we go. He snapped that picture of his boot print on the surface. Now, while they were there for the 2.5 hours, they collected soil and rock samples to bring back to Earth and performed many other experiments on the surface of the moon while they were at it. There is Neil Armstrong actually getting lunar dust picking up. And this is a picture taken from the LEM. They had a remote camera on the outside of the LEM that took this particular picture. But they had several experiments that were set up on the surface as well. One of them was called the Passive Seismic Experiment, and it was designed to detect lunar moonquakes and provide detailed information about the internal structure of the moon, which we did not have up until that time. And that should come up. Oh, first, Neil Armstrong snapped this very famous of Buzz Aldrin here. You can see Neil in the visor, and at the very top of his visor, you could actually see the Earth in the background. That is the solar wind composition experiment. They collected samples of the solar wind, then they rolled up that piece of foil and brought it back. There's Buzz Aldrin near the foot of the LEM as well. You can see their footprints on the lunar soil there. Those are still there today because there's no atmosphere. This is the passive seismic experiment, and behind it you can see the laser ranging reflector. If you have a big enough telescope, you can actually shoot a laser at their landing site and get the beam to return to you on Earth, and they actually measured exactly the distance of the Earth to the moon with that. They also collected lunar dust. As you can see, they put a flag. By the way, that flag, unfortunately, does not resemble Old Glory anymore. It's been out in UV light for 50 years. It's just a white sheet now. It's been bleached white by the sun's light. And here, once again, is a wide view of the entire lunar surface. After Apollo 11, there were 5 other missions that landed on the surface. There were 6 launched, but Apollo 13 didn't make it. They had trouble and had to turn around and return to Earth. But during those 6 missions, the astronauts brought back 842 pounds of lunar rock, sand, and dust, allowing scientists to scrutinize the moon's surface. From this, we've learned a wealth of information about the moon's formation and evolution. Early in its history, vast oceans of magma blanketed the moon, and as the magma slowly cooled and crystallized, less dense materials floated to the surface. Much of the ancient lunar crust is made up of a light-colored rock called anthracite, which we see from Earth as the bright sections on the moon. After billions of years, however, that dazzling surface is now marked with dark tracks and speckles and splotches. Many of these dark zones are vast swaths of what we call lunar basalts, similar to the rocks that make up the Hawaiian Islands, known as Maria, which is Latin for seas, by the way. So the Sea of Tranquility, Maria Tranquillitatis. And this is Neil and Buzz returning to the command module. That's Eagle that you're looking at there. The command module was named Columbia, which they named the shuttle after later. The second shuttle to be launched after Enterprise, the first one to go up into space. Scientists don't think that the lava eruptions are still going on. They most likely happened in a burst 3 to 4 billion years ago. At the moon's center is a small iron-rich core. Just like the Earth has an iron-rich core, so does the moon. The iron-rich core of the moon, though, is only 300 miles across. Now, when you're learning how to walk in 1/5 gravity, there are some issues. The other issue is these spacesuits that they wore at the time were very, very rigid. And as you can see, it was like learning how to walk all over again. When Michael Jackson did the moonwalk, it was because that was a way astronauts often got back up. These are some of the later missions. Apollo 12, 14, 15, 16, and 17 also returned all these samples and put things up. This is a fun one here. He was trying to put something in the ground. Oh, nope, that didn't work. So he's kind of flipped over there and he'll have to get back up. We know about the iron core on the moon because of seismic records from that experiment that I talked about with the Apollo 11 mission. So with future missions, they also had bigger LEMs, and with the bigger LEM, they actually had a collapsible rover they could take out called the Lunar Roving Vehicle, so they could get further and further away from the lens. And they also spent much more time on the surface than Neil and Buzz did. Many days, as a matter of fact, in the case of Apollo 17, which landed on the moon on December 11th, 1972, and returned to Earth December 19th, 1972. We have not had any humans on another body besides the Earth since that time. We have astronauts on the International Space Station, as we have for the last 20 years. We've had astronauts in orbit and on other space stations, but we have not landed on another body in our solar system since December 11th, 1972. That last crew, by the way, had an actual geologist on board. His name was Harrison Schmitt, and they returned very good samples as well, including the first non-gray rocks that were ever found on the moon. Here they are on the lunar rover right here. So the Apollo program has taught us a lot about the moon. It has been 50 years since we have been there, but hopefully it won't be that much longer. And to tell you more about that, I'm going to turn you back over to Tiffany.
Wow, that was awesome, Kurt. Thank you. And
And I'll be happy to answer questions on Facebook and after Tiffany's talk, if anybody has any.
absolutely. Yeah. And I want to point out that Kurt made that video. He cut together all the footage and things. It was really good. And I learned something.
That's what I do.
So, yeah. So my my talk is going to be focused on where do we go now? What are we planning? We haven't been back to the moon, or we haven't been on the moon or anywhere, as Kurt said, since 1972. Are we going to go back out and explore? The plan is, yeah. So I'm going to give you a quick sort of rundown as to what are our plans right now and the different avenues of space travel currently in plan and the plans that are in place, and then also talk a little bit about where we're looking further into the future. So let me share my screen real quick. So you'll notice that I'm just doing a little PowerPoint here. You notice in my first screen, it has the NASA logo, but it also has the logo of a private company, a commercial company, SpaceX. And that's because that's sort of the current situation for space travel. We can't ignore that commercial companies are going out and building their own technologies, incredible technologies that meet or surpass some of the technologies that NASA has built at a fraction of the cost and in a fraction of the time. So I don't have a lot of time today to talk about all these different companies. I'll mention a few, but I'm going to focus on SpaceX because they're the ones that are working with NASA a lot right now. But Boeing, for example, is right behind SpaceX in terms of technology that they're building. They're building rockets that can go out into space and spacecraft that can hold astronauts, can hold people for both shorter distances that are like at the International Space Station, and then further, which would be maybe like the moon. This is a new sort of model. Private companies have been building technologies for space since the Apollo era, but it was always government contracts, so the money always came from the government. NASA wrote the exact specs of all of the equipment, and the companies just fulfilled the order. It's a different game out there now. These companies are making what they want to make, and they're finding ways to make money doing it. So there's little niche groups. For example, the Blue Origin and Virgin Galactic companies are breaking into the space tourism business. Yes, they're selling tickets for normal, everyday people to go out into space. So they would leave the Earth, experience several minutes of of weightlessness, microgravity, right? And then they would come right back to Earth. So just like a quick little trip around the Earth. And I know what you're all thinking, because I always think it too. How much are these tickets? Where do I sign up, right? Or where do, how much do they cost? Let me think about this. Right now, the tickets cost anywhere from $200,000 to $400,000. Yeah, that's a lot, I know. So I don't know about you guys, but I'm thinking let's let the rich people with all the disposable income take the first couple of trips, work out the kinks, and maybe I'll pick up my ticket when it goes on sale on Expedia or something. But it's really cool that this is a possibility. Companies, in terms of the timeline, companies are ready to do this now. I think, especially with the situation that we're in, facing this global health crisis, I think it's going to be a little while longer, probably another year or two. But you will see, they have had a few people already go into space, and you'll see this happening a lot more, and very, very soon. We are also, SpaceX is also working very closely with NASA right now. I wanted to bring this up because mark your calendars. Later this month, May 27th at 4:30 p.m. Eastern Time, SpaceX will launch 2 astronauts into space off of U.S. soil. This is the first time this has happened in over a decade. Astronauts actually leaving the Earth from U.S. soil, and they're launching them to the International Space Station. So this is also going to be the first time that a commercial airline has launched astronauts into space. Now, while this is kind of important for our country, we still have sort of this friendly rivalry a little bit with Russia when it comes to space because of the Cold War, where it wasn't so friendly, but also it does drive progress. So, NASA had this the Space Shuttle program, and it was retired in 2011. So it's been over 10 years since NASA had a Space Shuttle sending anything up. And ever since then, the U.S. has paid Russia $85 million per astronaut to go up, to fly a Soyuz up to the International Space Station. So we're going to be able to do that now from our own country and at a fraction of the cost, thanks to SpaceX. You can see here in this photo, to the right here is a picture of the SpaceX rocket. It's Falcon, the name of the rocket. And at the very top here, you'll see the capsule. That's the Dragon spacecraft. So this is what actually physically docks to the International Space Station here. They have been doing this for years now, since 2012. SpaceX docked a Dragon spacecraft to the International Space Station, first commercial company to ever do this, back in 2012. And since then, they've been bringing cargo. So they've been bringing equipment and different things to the International Space Station. They've also been launching a ton of satellites into Earth orbit. And that's all I'll say about that. Oh, the really cool part about this, I'm gonna be nerding out a few times, but especially about this. Yeah, if this isn't cool enough that they've built a rocket, that it can go out into space, it can dock with the International Space Station and bring astronauts on board. The rockets, if I can figure out what button goes forward. Go forward. There, the rockets come back to Earth. They land, they go into space, they drop off the payload, they come back to Earth, re-enter Earth's atmosphere, and then land on this tiny little dock in the middle of the ocean. And they're reusable, so SpaceX can reuse a huge portion of their Falcon rockets. Isn't that amazing? I remember watching this live. It might not have been this exact one because they've done a ton of these tests, but like 2 or 3 years ago, I think it was with physics and astronomy students in their little study lounge, and we watched it land, and it was just the coolest thing. So it's definitely a different world now that these commercial companies are involved. This is a quick sort of overview as to how the Falcon launches, it leaves Earth's atmosphere, it does the first stage separation, this part is lost, but then the Falcon rocket will do this cool little twisty thing and then just come right back on down to Earth while the payload continues on. Now, NASA negotiates with SpaceX and has negotiated for this May 27th release later this month, where they launch astronauts into space. And I know that one of the stipulations that NASA had was that they use brand new Falcons. So I think everyone's a little nervous that this is sort of new technology. And when we're talking about human cargo, very precious cargo, we want to be as safe as possible. So they will be on brand new Falcon rockets. I did want to mention that SpaceX has another rocket called the Falcon Heavy, which is the equivalent of 3 of these Falcon rockets put together. And it's meant for longer travels, perhaps to the moon. SpaceX, the company was founded, I think it was 2002. And they said that their goal was to one day create a settlement on Mars. So that's their long-term vision. But are we going to go back to the moon? I hear this all the time, right? You probably heard about this. This is the Artemis program. If you're familiar with Greek mythology, Apollo and Artemis were twins. So this is very apropos for NASA to call their next mission to the moon Artemis, Apollo's twin sister. I'm going to read to you the Artemis program mission, because I think it sums it up really well. With the Artemis program, NASA will land the first woman and the next man on the moon by 2024, using innovative technologies to explore more of the lunar surface than ever before. That's the cool part. We will collaborate with our commercial and international partners to establish sustainable exploration by 2028. Then we will use what we learn on and around the moon to take the next giant leap, sending astronauts to Mars. So the Artemis mission is really to get people to go back to the moon, but for completely different reasons. We're not just visiting now. We know a lot more about our natural satellite, and now we just want to explore. We want to build infrastructure on the moon and explore it further. So here is how NASA plans to launch the Artemis missions. It's with a brand new rocket. You can see it's a little bit shorter, just 40 feet shorter than the Saturn V, which is what brought the Apollo missions out into space. But it is much more powerful. It is the most powerful rocket ever built, and that includes the Falcon Heavy. That includes any commercial rockets right now. And you might be asking, why aren't they working with commercial companies? Especially when you look at how much money they're spending. They are spending so much money building this rocket, they could have an entire fleet of Falcon Heavies at their disposal. Just per year with how much money they spend. So they spend an astronomical amount of money, but that is kind of always been NASA's thing, especially when you compare it to private company numbers. They are doing this because this is what they need. This is the specs that they need for their mission, and there is no private company out there that currently meets those specs. So while this is the they're going to be using like the Orion spacecraft up here at the top, okay, and then this is called the SLS Space Launch System. It's the most generic rocket name I've ever heard. Definitely not as sexy as Falcon Heavy or Dragon or whatever, but it's the SLS, and it's going to get the job done for what NASA wants for the specific mission. But I would be very surprised to see NASA not working with these private companies in the future. And I do want to stop here and say really quickly, if anyone's concerned at all about these commercial companies sort of edging out NASA, that is absolutely not going to happen. This is not an either or situation. It's an and. Space is huge. There's plenty of room for everyone to grow and innovate and explore. I think of it of an analogy to aircraft. So you need the government agency like NASA to work with these commercial companies to really get us far. As an example with the airlines, airports are all built by government agencies from countries all around the world, and our governments maintain those airports. And we also maintain security, right? The TSA is government funded, but private companies rent out the spots for their airplanes, and they're the ones that interface with the customers, and that's how the business models ran. So that's really similar to how it looks like things are going for space exploration. We'll have this sort of, government infrastructure built that NASA will build, and then the commercial companies will augment from there. This is a timeline of the Artemis missions. You'll see at the bottom here, the timeline is from 2020, this year, to 2024. So in 4 short years, they're planning first with the first mission to have the first human spacecraft to the moon in 2020 or in the 21st century. I will say that this has officially been delayed early March with the pandemic situation. It was officially delayed until April 2021. So the idea of getting to the moon 2024 seems really optimistic, but I think it's a wonderful goal. Do we have any questions at this point? We good? We can have some discussion afterward too, if that's okay. I just want to make sure.
Someone was asking if they ever planned on having a teacher in space, like a virtual classroom.
Yeah, absolutely. The neat thing about the space tourism, some of the companies that are sort of focusing on that aspect is they're planning on having like bringing up cargo that would be related to people's fields. So they would bring up lots of different people. A painter, they'd bring up their paint supplies. A teacher, they would bring up, make sure there's communication and any educational materials that they would need. So I think we're going to be seeing a lot. I think we're going to be seeing space from a lot of new perspectives and a lot of different in a lot of different ways and unique ways than we've seen before, which will be, I think, a positive outcome of this commercial company involvement. Let's see. I wanted to describe shortly the Artemis 1 mission because it's really cool. They're not going to be landing on the moon. So you're kind of thinking, oh, that's a bummer, right? Oh, we want to see them walk on the moon. Okay, but this is the first mission. Okay, so but they are going to break several records. First, they'll be the first people to the moon in the 21st century. They're also they're going to go around the Earth. They're going to spiral around the Earth a couple times, slowly spiraling outward, and then they'll hurtle out into the moon, and they're gonna get real close to the moon's surface. They're gonna hover at the nearest point. It's like 62 miles above the moon's surface, so they're gonna be really close. And then they're gonna slingshot around the moon to a really far off point, further than anyone has ever traveled. So they will technically, the Artemis 1 astronauts will be further in space than anyone has ever traveled, ever. And then they will slingshot back, straight back past the moon and back to Earth. So they're not even orbiting the moon. They're just doing like a quick slingshot. But this is a little bit of a proof of concept and to get the ball rolling. The second mission is to actually have people orbit the moon. And then you'll see 3 support missions. This is where we're building the infrastructure for the moon. So they're building a lunar terrain vehicle. It's like a rover, but it needs a human pilot. So think like super sophisticated dune buggy. Okay, the astronauts would need an EVA suit because they're going to be completely exposed to the elements. It's not going to be a comfy ride, and it's not meant for long distances. However, they're also building a habitable mobility platform, which is a bigger vehicle that is pressurized, fully contained, and it's meant for long distances, up to 45 days. So this is how the astronauts are going to really explore the moon. They get to go really far distances. And they're also going to build a Lunar Foundation service habitat, which is like a house for the astronauts. Up to 4 astronauts can live there for a period of time. But that is not where the astronauts are going to be staying most of the time when they're doing missions to the moon. This is the cool part. I'm going to be nerdy again, nerd out, because this is really cool. They're using the International Space Station as a model to build a smaller space station around the moon. They're calling it the Gateway Space Station. And just like the International Space Station, it's going to start real small and it's going to be modular. So over time, they can build rooms and new labs and add to the space station. And this is, and it's also going to have a docking station. So when the astronauts go to the moon, they're actually going to dock to the Gateway and live there and do most of the science experiments there. And then they're just going to go down to the moon and collect samples or do whatever experiments they need to do, and then they can come back up. So it's going to be a space station that's orbiting the moon that can come up and down when they need to. And this is going to serve not only future moon missions for however long, but it also will be a future way station. Think of it like a rest stop for when we explore further out. Our eyes are on Mars next. So after we do this with the moon, and we have that technology, we're going to learn so much. Then we'll have a little rest stop as we head out to Mars. Pretty cool. So do we have any questions at this point?
I'm happy to answer questions about the Apollo program too. I would point out that Wernher von Braun originally, before the space race started, wanted to build a space station, then build the craft to the moon at the space station, then build the mission to Mars at the moon, and then build the mission to the next spot at Mars and work our way out like colonists. But then we had to beat the Russians, so they just said, forget the space station, we're just going to the moon. And we did the International Space Station years later.
Yeah. Yeah, International Space Station is, I think, very underestimated in terms of what it's accomplishing for humanity, because it's not really doing anything notable enough for us right now, and that's just a human thing. We want to know now, what are you producing for us? Why are you so special? But using it as a proof of concept for future space stations, that's where I think the real value is. Not to mention all the just innumerable amount of science experiments we've done on the International Space Station. Space is like the perfect environment for science experiments. Okay, I don't have Facebook pulled up, but the students aren't saying that there are any comments. So I think we'll wrap up here soon. I know there's a little bit of a delay, so I'll wait just a little.
While you're doing that, Tiffany, I will let our audience know that if anybody is home and watching the noon news on Monday, I'll be on WFMJ's Noon News talking about what you just talked about, the SpaceX mission at the end of the month. And my cat waited until the very end, but Merope gets her words in.
Yes.
Yes.
We can't have a show without Merope.
Yeah, our space cat. But,
and I don't know if we've said this, but Merope is named after a star. Merope is one of
star cluster. Yes.
Yeah. So it's very appropriate that she's part of our shows.
Mm-hmm. I have Athena sitting next to me too. So.
Yeah. Great. So yeah, Kurt mentioned that he's going to be on the local news here in Youngstown next Monday, May the 4th. As in, May the 4th be with you. I hope you guys are finding reasons to celebrate. I've wanted
to be with you.
I wanted to do this show this week because, you know, we're all feeling kind of stuck. We're feeling stuck at home. And I think that the story of space exploration kind of shows us what we can do when we feel stuck, because we're stuck on Earth. Like, maybe we don't spend a lot of time thinking about that, but we have always just been stuck on this planet. And it took a lot of creativity and a lot of ingenuity to get off. So I think that's a really cool story to share right now.
I'd like to add, I'm a little more cynical than Tiffany. I think it's getting to the point where it's not cost effective for governments to launch these missions to things. There's a lot of science there. That's why I'm excited to see groups like Elon Musk's SpaceX and Blue Origins and Virgin Galactic come up. If you remember what it was like when, well, nobody alive today remembers this, but when airplanes first came up, there were all these different companies making different airplanes, and they were flying all over the place, and the government created the FAA to regulate, is this plane worthy to fly? Is this plane safe for people? That sort of thing. I eventually see down the road, NASA's role in space is going to be what the FAA does for air flight, and then private companies will exploit and return the resources and do the science out there eventually. That's way down the road, but that's what I see we're heading toward in the future.
Yeah, I mean, it's not a perfect comparison, but I think there is a lot of overlap or a lot to be compared with the airlines versus the spacecraft. And, you know, private companies going out and exploring new planets and the moon even just opens up this huge can of worms. Like, who owns the land? Who owns the property? Who owns the moon rocks? You know, what happens if they're really irresponsible and create a situation in space that would be detrimental to people in the future, like excessive amounts of debris. I mean, that space is big, so that's not as big of a problem, but you know, there's all these things to consider. And so there's going to be some growing pains, but it's exciting to see a lot of traction. Just in the last 5 to 10 years, we've seen a huge amount of growth in this area. Okay, it doesn't look like we're getting any. Jenny, do you have a question?
Yes, Terry asks, what is the best thing we've learned from the space station so far?
I'll field one thing that I think is really important. We had one of the astronauts who was an identical twin visit the planetarium. His brother was on the International Space Station for almost a year while he was on the ground. And then when his brother came back, they compared what happened to these identical twins during that year. So we learned an awful lot about what being in a microgravity environment can do to the human body over an extended period of time. There are also experiments that can only be conducted in space, special materials that can only be made in a zero-G environment, things like that we can't create here on Earth. And there are dozens and dozens over the last 20 years that the space station's been up there that we've been able to discover.
It's really hard to rank them. I think the Marks and Scott, the Kelly twins, the astronauts, experiment was amazing. But they do they actually work to develop vaccines in space. It's an environment that's good to really study viruses and how they interact with things. So space medicine is a thing, and I think, to me, what's special about the International Space Station is what it's going to give us that we can't predict. It's sort of like that gift that keeps on giving. I think just having a science lab in space is just opens up a whole world of possibilities.
Kind of like the Hubble Space Telescope. We didn't know what it would discover, and here 30 years later, we know so much more thanks to it.
Yeah, you can make a good argument that that the Hubble Space Telescope is the single most successful, has given us more scientific understanding than any individual instrument of mankind ever, like that mankind has ever created. So not telescopes in general, but if you're just looking at Hubble, it has given us more more understanding, more data than any other instrument. It's really cool to think of it that way. And we just thought it was going to be a telescope. I mean, that its mission ended, I don't know, 20 years ago or something. I can't remember, but it did not have a plan to live for 30 years. Okay, we should probably wrap up the show. I just want to mention that next week our show is going to be all about our neighboring planets. We're going to really focus in on both the planet Venus and the planet Mars. And I am making it a personal challenge to for any of you space buffs out there that you're like, I already know about Mars, I already know about Venus. I will teach you something you don't know. Okay, so we're going to find some of the really cool, interesting facts. And I'm also going to talk a little bit about how we know what we know, which I think is usually the stories behind how we figure out what we learn is sometimes just as interesting as the discoveries. Okay, I think we're going to wrap up. Thank you guys so much for another successful show. Thanks for coming back and watching with us, and we'll see you next week. In the meantime, keep looking up.